Thank you, Adrian, and welcome everyone. It's my honor and pleasure to be able to get up and speak a little bit about our initiative with electric vehicles and more specifically personnel carriers at our mine site. My colleague, Dwayne Gaudette, Adrian gave us fancy titles, but what it comes down to is Dwayne is a heavy-duty mechanic and I'm an electrician. Heavy-duty as well, but not quite as heavy-duty as Dwayne. At any rate, we consider ourselves to be the primary drivers of this initiative at Musselwhite, and we hope that the focus of this discussion is to underscore the difficulties that we've had achieving acceptance of something new and something that we consider to be very good. And I had hoped that the discussion would be a little more interactive, but due to the time constraints, I can see that we're going to have to present the material and hopefully have an opportunity for a little more interactivity during the panel discussion. So, being a heavy-duty electrician, I'm technologically challenged and can't advance the slides. Yeah, I guess there's no control apparatus on the screen, right? So, by way of introduction, Goldcorp has we're proud of our presence in Ontario, and there's just a little bit of a background there about our contributions to the economic and social benefits. And we are one of the senior gold producers in the world. Ontario is critical, important jurisdiction of Goldcorp. The mines in Ontario are the only active mines that Goldcorp operates north of the Mexican border. And we're also responsible for about 1/3 of the total of 3 million ounces produced annually in the Americas. So, proud of that as well. At Musselwhite, we're engaged in about a $90 million investment to expand our production and extend our mine life, create jobs, and all of the associated economic benefits that go along with that. But even after an effort in energy conservation and a resultant reduction in diesel fuel that I'll get to in a bit, the mine remains grid constrained at just under 20 megawatts, which is to say that's all we can draw from the utility. And it's a challenge. So electric vehicles underground, once I connect the dots, are but one way under consideration to remaining viable in the Goldcorp family. Musselwhite Mine is located in northern Ontario, 500 kilometers north of Thunder Bay, Ontario, which sits at the head of Lake Superior. The name is kind of a funny one, and people wonder where it comes from, but it's actually the name of the two brothers who originally staked the claim back in the mid-'60s when rock and roll was king and the Leafs had a contender back in my time. And so I look fondly back on those times, but that's where the name comes from. It's simply the name of the two brothers that did the initial exploration. So And some of the names of the communities, those are First Nations communities, and they're stakeholders that we've engaged in partnerships with. And we're very proud of what we call the Musselwhite Agreement, too. There are some 14 different First Nations communities that are part of our agreement with whom we work together to develop and continue making Musselwhite a success. That's our corporate vision and strategy. And so we have developed 6 pillars, and they're there for your inspection. And we are committed to being responsible stewards of the environment as well as viable gold miners. There's, this next slide is an indicator that shows the location of our 4 Ontario mines, 3 in operation and 1 soon to become operable. The stats on the side would indicate that again, kind of bragging rights where we're highlighting what our accomplishments are in the province. And on the right, you'll see the location of our 4 sites and our regional office in Toronto. Now, the Borden Gold Project is a very exciting initiative that, if time permits, at the end of the presentation, I'd be happy to spend a few minutes on, but that'll be a total electric mine, a mine of the future, a mine that's being developed at present. And we're all very excited about that one. So that would warrant a presentation on its own for sure, but it's in the development stages right now. So, but you can see Musselwhite is just above 52 degrees latitude. It's cold. It's a continental climate. There's no moderating effect from any big body of water. So we're true northerners up there. Being a fly-in, fly-out site, one of our advantages is that we not only work together, but we live together. So we've learned how to support one another, and we've learned how to argue and disagree without taking it personal. And I think that that gives us a very unique advantage over a lot of other sites. Back in 2011, our corporate COO came out with a strategy for energy management, for energy conservation. And we at Musselwhite have achieved, I'm proud to say, have achieved all of the criteria and then some. So we're looking at that corporate strategy again for the next 5-year plan. And hopefully everybody will be on board. And this is not just the Ontario sites, but it's Goldcorp wide. So the details are there. One detail that's not there is with respect to renewables, because in 2011, renewables were something that was difficult for the mining industry, and still is to some extent, to grasp and determine, you know, just how we would implement such a thing. So, specific to Musselwhite, we realized back in 2013 that our energy consumption was running rampant, out of control. Costs were crippling, and greenhouse gas emissions were way up. And one of the biggest reasons for this was because of our grid constraint, our power constraint. and we were running 23, 24 megawatts during peak production times. So at the end of 2013, I was pulled out of maintenance and assigned to energy management with the hope that I could help the site to shut down the diesel generation that we were using to supplement our grid power. And with cooperation of the production teams and a lot of strong arming and discussion and quite a bit of whining and complaining, we were able to reduce our power consumption to the point that I was able to shut the generators down. And you can see by the bar graph there that not only did we cut diesel consumption in half, and that just represents getting diesel generated electricity online. What's left is diesel powered equipment that I'm building towards. So my intent before my time is done is to have that little orange bar go to zero when we're all electric underground as well. So the diesels are gone for now, and the next step is electric vehicles. But we were able to achieve this reduction in diesel-generated electricity, and I think the thing I'm the most proud of is that if you look at the blue bar, which represents electricity from the grid, not only did it not go up, it actually dropped a little bit. That happened through conservation efforts to reduce base load and some very aggressive peak demand management. And it wasn't done with fancy equipment. It wasn't done with VODs and variable frequency drives. It was done with a little bit of programming to take discrete loads offline when we approached our grid limitation. But the biggest thing was the behavioral change. The fact that the fellows that work in the underground environment had to come to realize that when they walked away from a 6-inch header of compressed air at 110 psi without shutting it down at the end of the shift or between shifts, that costs a lot of electricity. But most miners, most people not engaged in energy management or some sort of technical discipline don't equate compressed air to electricity. The same fella that guy or gal that would feel good about turning the light switch off in the bunkhouse when they left to start their shift could leave the heading with 600 or 800 horsepower of auxiliary ventilation fans running and nobody in there, no need to ventilate, not understanding that that power that they're walking away from is enough to supply the whole bunkhouse and kitchen complex. So it was these types of behavioral changes that allowed us to get 3 or 4 megawatts off of diesel generation and start using electrical energy a little more wisely. So I talked about being constrained for power, and this slide illustrates why. We're at the end of the longest radial transmission circuit in the province. Half of it is owned and operated by Hydro One under the jurisdiction of the ISO, and it's a very tiny line. It's not very robust. It's subject to lightning strikes because it runs along an east-west thunderstorm corridor. And the demarcation point for us is at a little community called Pickle Lake. So for about 200 kilometers, we operate and maintain our own transmission circuit that runs north from Pickle Lake to the mine site. But the bottleneck is the E1C, the designated E1C transmission line that the utility owns. So that creates all sorts of issues for us, not the least of which is the power constraint. The outages due to the lightning strikes and the thunderstorm season are very expensive as well, as you can see. So, to the point of the presentation, in the spring of 2014, I attended an OMA Energy Committee meeting here in Toronto and caught a presentation by a fellow by the name of Patrick Burns. And he was the owner and originator of Papa Bravo Innovations. And he spoke about an electric personnel carrier that he was trialing in the potash industry. And he spoke with such passion and conviction that I was sold. And we had some discussions afterwards. And I went back to my mine site and I spoke with my mine general manager. And I tried to convey some of the passion, some of what I thought would help, some of what I thought why I thought this would be a good thing for us, and was given permission to proceed. So proceed we did. And right away, I apologize, my slides are, what's that? Okay, well, what we're going to do is Dwayne and I are going to split this up, Dwayne being the technical expert with respect to this equipment, me being more of the electrical guy that is trying to implement the change process. And we're going to talk a little bit now about the trials themselves and how they proceeded and how they, some of the hiccups and some of the comparisons between the electric personnel carriers and the conventional diesels.
Good afternoon. So anyways, when Howard came back and we talked about this, it really piqued my passion, because one of the things I had to do in the last few years would deal with a pretty major DPM problem in our mine, which all of you know is a known carcinogen. And we had some areas where we're respirator fit only, and we went down to where we got rid of that. But for us to move any further, we actually had to really think about what we were doing. So anyway, when we went to the, when we first looked at these, we looked at the purchase costs. Purchase costs were comparable to what a Toyota man carrier were, and so we went forth with that. So some of the claims we were having that we'll have a 80% reduction due to minimal moving parts. The electrical infrastructure for charging, we had to put on 4 levels so that we can trial the vehicles. You know, the other thing that was really good for us was charging's done on in between shifts. So if you think about our power consumption, our highest is during the shifts, and in between shifts it's low. So that is the best scenario, because really that's what you're trying to do, is to shave off those peaks and valleys. So if you go to electrification of vehicles, that's what you want, right? You want to be able to have more consumption between shifts to level you off, right? Okay. So I got to move along here. We're a little bit on the slow side here. So impact on mine ventilation, of course, is diesel fuel savings and reduced greenhouse emissions and lower DPM values. The first vehicle we trialed, one of the 2 vehicles we were trying was Minecat from Industrial Fab out of Sudbury. Some of the items here is, you know, we've incurred some costs for some warranty issues, and both companies have been very good. We've partnered with both Minecat and we've partnered with PMP, and both companies have been very good. And that's the whole idea, is to partner with the companies, because that's, for us to get this off the ground, we need to have good relationships. So everybody will have this slide pack at the end to go through. Just some updates that they've done in the last little while. And one of the bigger ones for both of them, we upgraded both batteries so that we're getting a full shift out of them. So if you take a look at the initial trials, they're usually with the Toyota, depending on your mine, you're spending about $56,000 on these things, especially when they get older. So right now we've spent very little on our electric vehicles, about $5,000 in 2016 and about $6,000 in 2015. Really spent nothing on parts, it's just maintenance costs. Our upgrades this year, of course, is the battery, and we got a 40% more range and some of my diagnostics, right? So here are some of the concerns. That's what we're really working on, is to lower the concerns and to make this make this work well for the people that drive them. If we don't get the buy-in, that's really where we fail. So some of our positive stuff: good visibility, comfortable drive, minimal power loss when fully loaded. And then, of course, our PMP trial is we did a battery upgrade, and that also gave us 45% more charge. And again, there's some little items that just for mostly for driver comfort. And that trial there is spent about $5,000 just for a site visit at one time. Some parts, about $2,000, and we've put on 4,000 kilometers as of October 6 and 482 hours of October 6. And we bought this item and we've rented the other one. And typical, as I said before, $56,000 for the year, but this one cost us at $8,000 and $10,000 in 2015. And really minimal things, but all this is like trial and error this year. The Papa Bravo there, we've also had some minor things, and a lot of it is regeneration in the braking system on the downhill ramp, because that's what makes people feel secure with that, right? Our new battery has now proven to have about a 40-kilometer range on the ramp, which is phenomenal, really is, and that's up and down the ramp and throughout the mine, so pretty phenomenal if you ask me. And our ramp is at a 20% grades in areas. And then Howard's just going to speak to the resistance to change here.
So I'm just going to wrap this up very quickly because we're over on our time, but and you've all got access to these slides, but the resistance to change was very significant. This is the operator resistance to change. Mandated compliance followed that because it was the only way to get people to trial these things. Gradual acceptance, which we knew would happen. We're not at 100% yet, but we're getting there in a hurry now that the miners are using the electric vehicle. And this led to what amounts to really my vision for the future, but it's personnel carriers, boulders, jumbos, and boom trucks, which we're trialing right now. Trucks and scoops will be next, integrated into the capital budget for fleet replacement, so there really is no CapEx. And then concurrent strategies will be developed to promote demand management to flatten daily electrical load profile, keep us off of generation. Renewables will hopefully be what we use to flatten the peaks and fill in the valleys and provide for the additional charging. Next steps. Personnel carriers have now been approved for replacement of diesel-powered vehicles when they come up for change out in the budgetary process. Boom truck, as I said, trial has been completed, approved for purchase. As the fleet grows and refinements are made, we'll continue to promote diesel-powered mobile equipment. no downside. Why would anybody combust fossil fuels in a confined space when there's a viable alternative, right? And that's from the health perspective. But what we need is vendor partnership and support, because this is still an emerging technology, as our Borden mine site is proving. And these are all areas that we have to continue to assess and improve. And, you know, I think a lot of these topics will be detailed a little more elaborately in our panel discussion. Thank you for your attention.